Hello, my name is Adele. I'm here to give a short tutorial on data wrangling at scale using Data.table in R. In this tutorial, we will learn to manipulate, modify, and summarize data, as well as chaining and joining datasets and plotting using the Data.table package. First, let's talk about what's data wrangling and why is it so important. Data wrangling is the process of gathering, assessing, and cleaning the data. It is used to transform the raw data, which are typically not clean and well-structured, into readily analyzable formats to be used for analysis, modeling, and visualization. Data wrangling usually takes 70 to 80% of the time, leaving only 20 to 30% to the actual model building and analysis. That is why data wrangling is a very crucial step in any data science project. Now let's dive into the Data.table package. Data.table provides a high-performance version of base R's data.frame with a convenient syntax and high-speed programming. It's also memory efficient, has a large community online, and contains rich features and functions. We will learn all of these aspects in a second. As usual, we install the package and call the library. Now let's discuss how to import a CSV data using the fread function or fast read. We downloaded or we imported the empty cars CSV data using fread and assigned it to an object called empty. Let's check how fast fread actually works compared to read.csv. We created a large data frame called trial with 1 million rows. And as we can see here, fread is actually at least 20 times faster than read.csv. Now let's move on to creating data tables. First, let's use the built-in R data called air quality. And we see the class of air quality is actually a data frame. To convert this data frame to a data table, we can either use the function data.table and ask.datatable, or use the function setDT. First, let's use ask.datatable air quality and assign it to ask air quality DT. And we see that when we use the class air quality DT, it actually becomes both a data table and a data frame. Now let's do the same for the empty cars CSV by importing it using fread and explicitly assigning it to ask.data.frame to show that the class of empty is actually just a data frame. Here we use the setD function to empty, and the difference of that to ask.data.table is that we do not need to assign empty to a new variable, to a new object in order for it to be a data table. Here we see the class of empty becomes a data table and a data frame as well. For illustration purposes, we will use the empty DT object as the data table's version of the empty cars data frame. We can also manually create a data table using data.table. Here we created 8 rows and 3 columns, X, Y, and Z. Now that we learned that a data table is also essentially a data frame, packages and functions that work with data frames also work for data tables. For example, here we use the function names. It returns the column names of empty DT, the dim or dimension. It returns the dimension 32 by 12, and the structure or str function of empty DT. And finally, we will use this empty cars data set later on for all of our examples. Now let's discuss the data table syntax. When compared to a data frame, the basic arguments within brackets are not row and columns, but they are rather I, j, and by. For example, a data table dt, I, j, by translates to take dt subset rows I, then calculate j group by a by variable, or this is usually a categorical variable. Now let's compare how to filter rows using conditional statements in a data frame versus a data table. In a data frame, as we can recall, we always use this prefix empty $sign when we want to call a column name. For a data table, actually, there are perks for using it because we don't always have to write down empty $sign, and we condition the statement as number of cylinders is equal to 6 and the number of gears is equal to 4, and it returns the same results as this one. For filtering rows, it's quite similar to a data frame. Here we select the first row by indexing it as 1. And here we selected the first 5 rows. Actually, if we select rows in data tables, we actually do not need to put a comma right after the index, and it works perfectly fine. Finally, for subsetting columns, it's also the same for data frames. We put it right after the first comma or the J argument. Here we selected the first 2 columns, car name and MPG. We can also select columns via its name. We selected here the MPG variable, and it returns the vector values of MPG. The difference of this code to here, when we put MPG in quotation marks, is that it returns the whole column of MPG. And we can also select multiple columns using list and putting a dot and parentheses. And inside the parentheses, we put the columns that we want to select. And that's this line of code here. We use the list MPG CYL, and it also works as this one. And we have selected both MPG and CYL columns only. If you want to select multiple columns using a character vector, we can also create a character vector containing MPG, CYL, and disp. And what we have to do is put the character vector in the J argument and add this width is equal to false. You have to remember that if width is equal to false is not here, then it will return an error. But if you're too lazy to put this thing, what we have to remember is just put 2 dots right before the character vector's name, and it will return the 3 columns or variables that we want to select inside the character vector. For subsetting rows and columns, we just have to combine the things that we just learned. And for modifying variables, for example, we want to drop the character vector or the columns that's inside the character vector. What we have to do is just put this exclamation mark, and remember this width is equal to false has to be right here. And it also works this one, and we just put the exclamation point right before the 2 dots. For renaming columns, we only have to use the function set names. Here we renamed the VS variable or the original variable to engine underscore type. So the syntax is set names. Inside the parentheses is the data table names, mtdt, comma VS, and then comma engine underscore type. We can also rename multiple columns by indexing here. We rename it to horse underscore power and rear underscore ratio. To assign and save new variables, we have to use this special symbol, colon equals sign. And here we created a new column called CYL underscore gear, which is the sum of the number of cylinders and the number of gears. So again, we put it in the JET argument right after the first comma. Next is, if we want to create multiple columns, we just have to put the colon equal sign between 2 back quotes. And here we created 2 new variables, the product of CYL gear and the difference of CYL and gear. To summarize data, it's also similar to creating variables, but what we have to do is we have to use functions. For example, here, the mean, the summary statistic that we want here is the average horsepower, and we have to put it as well in the J argument, and we assign a name here, mean underscore HP. If we put this dot here right before this one, it will return the header or the column name that we assigned, which is mean underscore HP. If we also want other summary statistics, such as the SD or the standard deviation of the horsepower, what we have to do is just add this code. And again, remember, put this dot because we're returning multiple results. We can also summarize by group. Here we use the by syntax of the data table. And it's right after the J column and then after the comma by engine type. And finally, we can now discuss the concept of chaining. Chaining is like piping in dplyr. We only need to attach square brackets at the end with the next method to add an additional step in the analysis. We can do multiple data table operations one after the other without having to store intermediate results. For example, here we wanted the average of 4 variables mpg, disk, wt, and qsec, and order the results by the number of cylinders. What we do here is we use this line of code and we group by cylinder. So we can see here the number of cylinders is not sorted yet. What we have to do is just add this line of code inside the square brackets, order CYL and then comma, and then it will sort the results 4, 6, 8 to the number of cylinders. In joining data tables, let's first discuss the concept of a key. To set a key of the data table empty dt, we just have to use set key empty dt car name, and the car name will be the key. We can also use or set multiple keys by adding just another variable that we want to set. Next is, remember just before the chaining example that we did, we summarized the 4 variables mpg, disk, and wt and qsec, and we wanted the mean by group cylinders and order by cylinder by the number of cylinders. There's actually a shortcut for this chain using the syntax key by is equal to CYL. Just note that it should be the by group and the order must be the same. It's both CYL. And this CYL must be, we must first set this as the key because we set it here. So it works perfectly fine. To join data tables, now we've learned what a key is. It's crucial here that we set the key to car name because we're subsetting 2 data tables from the empty dt. dt1, which has 26 rows and has 3 columns, including car name, and dt2 has 10 rows, which has 2 columns, car name and gear. To merge these 2 data tables, what we have to do is just use the function merge. And here we use merge dt1, dt2 by car name. Car name is the key. And this code actually, the results is like an inner join. It means that it only returns the rows that dt1 and dt2 have in common. For a left join, which means that if we want to just return just the rows of the first data set or dt1, or we're using dt1 as the base, what we have to do is just add all dot x is equal to t. And if we want to use the outer join, which means that all the rows of dt1 and dt2 must be retained, we just modify all is equal to t, and it will return all the rows included in the dt1 and dt2 data tables. To plot data, we can also make simple and quick presentations like this scatter plot and put it in the J argument. Here we plotted MPG versus DRAT, and that's it. I think we've covered a lot of things about data wrangling, and we're now ready to have an exercise on data wrangling. Thank you very much for listening to this tutorial.